Hi everyone, my name is Matt McMahon. I am an Unreal Authorized Instructor and Emerging Technology Lead here at New Media Manitoba in Winnipeg, Manitoba. I wanted to talk to you all about the ideology behind RealityScan, from processing to rendering. And the idea behind this class is to make it so that when you've already gone out, you've taken your images using your standard photogrammetry techniques, and after you have accomplished that, we now need to ingest all of that information directly into RealityScan so that we can start to get a ideal fidelity output. And so what I wanted to talk to you all about today is kind of the process of going about doing that and the different phases that it requires so that we can get a solid rendering output from RealityScan, because the quality is quite impressive as far as like what you can actually get. And it's all about making sure that we give ourselves enough data to leverage, but then also utilize RealityScan to its fullest. So for our agenda today, I just wanted to go over basically a quick workflow refresher for those who haven't necessarily done some of the basics. This class is going to be gearing a little bit more towards the intermediate side of things, but like I just wanted to do a quick workflow refresher for how you go about actually doing scans in RealityScan. Then I want to talk about post-processing essentials, so like what the reconstruction region actually is, how you go about mesh cleanup, talking about some texturing, then how do we actually optimize for our delivery targets, so things like mesh simplification, how do we handle our texture count, LODs, everything like that. For those who don't know, LODs are level of detail, so this is often utilized in when you are exporting to something like Unreal Engine or Unity, something where you want to have various qualities based on distance away from the camera. I also want to quickly showcase how you can actually do some really cool like rendering. So through like either like an animation or stills, even like it honestly like RealityScan does a really great job at being able to render out some absolutely fabulous looking renders. It is really important to note that when you are looking at a mesh that you've created in RealityScan, the way that it actually is rendering is it's rendering similar to what's called the like an unlit mode in something like Unreal. So basically, it's the overall image is as flat as possible, and it's not actually being rendered out with proper lighting and shading. Just something to keep in mind. Then we will do a quick recap, and yeah, it's going to be a lot of fun. Alrighty, so for a workflow recap, let's quickly chat about the kind of like the pipeline. So the pipeline into reality capture is once we've actually imported all of our images and video and lidar and everything, anything that we've captured out in the wild, we need to follow this kind of simplified process. Basically, what the ideology behind it is, we want to do something called aligning all of our images. And what RealityScan will do is it will leverage each image, and it will actually place it based on where that image was taken within the local space. So if you are going around a tree or around a rock, every image will be aligned appropriately to exactly where that image was taken on that object, but also the exact camera angle that it was taken. And all of this information is leveraged through the image, but also the metadata. And that is actually how all of this stuff aligns together, so that you can start to create that sparse point cloud and start the meshing process. once we kind of have aligned everything together, we can do what's called the meshing process. And what will happen is reality capture will take the point cloud, or this like sparse point cloud that it created from the alignment phase, and it will actually start to triangulate between all of the points to start to create a mesh similar to what we would have in our standard, um, game slash CG workflows. And it really starts to really come together during this phase, because you can start to see all of the data that you did capture and some of the data that you didn't capture, and you can start to really analyze and understand what your potential final output will be, uh, before you even far before you even get to your final output with a texture. The next phase is what's often called like the refining phase. So it's basically like cleaning up and optimizing your mesh. So this is like decimating the mesh, in triangle count to make sure that it can load appropriately. It's creating your level of details, etc. Then, of course, you have your texturing phase, which is basically utilizing the actual textures of um, the images. So basically, what Reality Capture will do is it will take the images and it will apply those images as our texture maps. So a mixture of our albedo as well as our normal, and you can also do displacement maps. And it will apply all of those and create textures for us based on the parameters that we set. So going on to the next, what I'm going to do is I'm going to quickly flip over to our reality scan here. And so now I'm in RealityScan, and just for a little bit of context, I'm going to actually just flip to the sample data sets. If you want to follow along for this, I'm actually in the sample data sets, the RealityScan sample data sets community post. There's I there's so much here that you can just kind of leverage, and for this I'm using the tree stump example, the one that has 400 images. It's a really, really, really good data set to kind of, sink your teeth into and to practice with, because it's the quality of the output is quite good, and it also gives you a lot of excess triangles and things like that to kind of work with and to simplify with. So it's a lot of fun to use. So that is what I'm going to use for this course. Thank you to Epic for providing all of that. And so now that I've flipped back to RealityScan here, you can see that we have an image of our stump. And so on the left-hand side, you'll see under our inputs, we have, of course, all of our individual images that we can flip through. We can see everything. In the input, it tells us exactly like how this image was taken, like with what camera, the pixel format, everything like that. So, and it also tells us what our lens information was. So now what we can do is we can actually start to take a look at kind of like the now that we've gone through and done that, we can actually start to take a look at like kind of the alignment phase. Um, I have already gone through and actually done a alignment, and so the way that I did that was, if you go to workflow, I actually went to align images, and what it's going to do is it's going to take all of our images and it's going to showcase that in a basically like a kind of like a 3D view with a point cloud. And so I'm going to show you what that looks like. I'm just going to go ahead and flip. So at the top right here, I'm going to actually switch to my 3D view. And there we go. So I'm also going to turn on my cameras so that we can see all of our fabulous camera views. And what's really cool about this is that you can click on each individual camera shot to see exactly which camera was, or sorry, which image the detail is being captured from. And it also showcases to you like kind of exactly where floating in space, but also the angle at which it was all taken. So here we have what I would what is kind of classified as our sparse point cloud. And I'm just gonna flip back to a double view here so that we can see in more detail. But what's really neat is you can actually go through and you can actually take a look at all of the individual points that were kind of generated with this. And it starts to show you kind of like your overall topology of what you are actually looking at, and the type of data and the data set that you were able to capture with your cameras. There is, of course, you're probably also going to notice a lot of like excess. So there may be, you know, like excess points, like as you can see kind of down here, there's a lot of excess points. And maybe you do want that, maybe you don't want that. It really kind of comes down to each individual use case. But that is something that you will always kind of, you know, have to contend with. But really, what you're looking for is the overall shape and form. You're looking for overall feature qualities. You just kind of want to make sure that everything kind of looks good. For this class, I basically went through and I created numerous, not only did I align it, but I also went through and I created numerous meshes to kind of showcase a little bit of the difference as far as like difference between different quality of outputs. But then also I started to, and I will continue to show a little bit of like the simplification process and how we can go about and do that. But the real idea is about understanding why we do these things, and what the purpose of this is, and what our potential expected output is. Because honestly, like without understanding a bit of the why, it's hard to put it into practice. So let's go ahead and kind of jump into a little bit more of this. With alignment, like the core idea that I want to kind of set across is alignment is vitally important because it is the foundation for how our mesh is actually going to be built. So you always want to try to achieve the best type of alignment as possible. In this case, you can actually see that my component, or like my basically my aligned point cloud, it was able to achieve 400 out of 420 image alignment. So that means that it did a pretty good job at stitching all of these images together. But as you can see, there's also like a bunch of like smaller components. So there's, what is that, eight cameras that got aligned to basically kind of separated outside meshes that don't really join into the overall bigger point cloud. They're kind of just on their own. So in a perfect world, in an absolutely perfect world, we would have 420 out of 420 cameras. But it's not necessarily always feasible. It really comes down to the capture quality of your images, as well as how well your overlap was between them. There are of course manual ways that you may be able to remedy this using something called control points, but more often than not, it's better to try to follow your proper procedure with proper overlap, as well as, you know, making sure that your distances are well set. Um, Quixel and Quixel has done an absolutely amazing job with doing basically a photogrammetry fundamentals, and following those tips and understanding why you do those types of measurements, but also like the type of equipment you use, it's really, really good at like helping you understand why you do something when it comes to photogrammetry and LiDAR. Absolutely fabulous. It is also on the Epic community forum. I heavily recommend, if you have not read through those documents, through those forum posts, or sorry, I guess they're more like a community or like tutorial posts. I heavily recommend you do that. So we've gone ahead, and what we've done is we have all of these points, and they're all kind of floating around in space. The next step would be to basically mesh it into like into like an actual mesh. So I'm just going to quickly flip from our standard view mode to a solid mode. And right now, this is actually running on like a preview, like basically this is preview quality. So this is only about 385.3 thousand triangles. And as you can see, like it's really the way that I view the preview is it's a good way to gauge where your topology is at. So it's a really, really good way to make sure that major features or landmarks in your overall mesh that you captured is actually getting captured. And it really, really kind of helps because it's so much faster to render out a preview mesh than it is to render out even a normal quality mesh. I will show the next one up, which is the normal quality mesh. And as you can see over here on the left-hand side, we jumped from 385.3 thousand triangles to 83.5 million triangles. You can see that the quality is quite a bit better. Especially of the stump. It's actually quite a lot better. There's quite a bit more detail in the stump, in all of the actual individual, like the actual meshing of the stump. It's quite a bit better, and this is because it was able to actually leverage more data out of the images. So that's how it was able to do that. Then what I did was I then processed a high quality base. So this is basically the kind of like the max quality we could get just by running the algorithm alone, out of this. And so I'm just going to let this load up. It's going to take a little bit, but basically we made another jump from 83.5 million triangles to 265.6 million triangles. So as my computer continues to try to load this up, it's key to note that RealityScan can use a lot of power. So I definitely recommend you have, if you start to get into higher fidelity meshes, or larger landscapes, like if you plan to do drone slash professional LiDAR scanning of larger areas, I definitely recommend you have a fairly strong machine to be able to kind of power through it all. I've definitely run out of RAM and other component, just just hitting the max, hitting the ceiling for specific machines. I've done that a lot. So as you can see, it's like my machine's running quite a bit slower now, but basically it's now rendering 265.6 million triangles. The quality is even better than the normal, but this is kind of where you start to see like a lot of diminishing returns, especially because like the jump between 83.5 million and 265.6 million triangles is quite a leap. But what's really great is that we can start to leverage, we can actually like create a texture and out of this, and actually start to we can basically project that higher resolution texture onto a mesh that isn't quite as nice to look at, to give us like a mixture of both sides. So if our mesh has not as many triangles, we will be able to run it well in something like Unreal Engine, but we want it to look visually good. So how can we do that? Well, we can do that by basically creating the texture on a way higher fidelity, way higher amount of triangle mesh. And then we're going to basically take that data, and then we are going to re-plaster it onto the one that maybe it doesn't look maybe it doesn't have nearly even close to the amount of triangles, but the texture will help kind of make it look like it does have more detail than the mesh is actually showing. It's quite impressive what you can do. So what I'm going to do is I'm just going to flip back to normal base here, if it will allow me to. And while that's going, I want to I'm going to flip back to my slide here, and I want to kind of just quickly start talking about, so like now that we've gone through and we've like created, so we have our three meshes, right? So we have our preview mesh. It kind of showcased to us a bit of the topology, like, and making sure that, you know, our major features were getting implemented appropriately. We have our normal mesh, our normal quality mesh, which kind of showcases in greater detail what the actual fidelity, like the direction that the fidelity is going. And then, of course, we have the highest quality one. So it's basically like maxing out the amount of triangles. So the density is quite heavy. It's a very, very heavy mesh, but it does allow us to extract out the most detail, especially in the textures in the normal map. But so now that we've done that, I want to talk a little bit about like, okay, like how do we start to like manipulate things and start to actually do things? So the very first ideology is the reconstruction region. So the reconstruction region is amazing at, let's say you have created a preview mesh and you're like, oh, I do not want to include all this other stuff. Well, you can actually go through and shrink the reconstruction region, which will make it so that it only calculates what, basically it's only going to calculate what's in the reconstruction region. So if you shrink the reconstruction region to a smaller area and you basically hit like a line, it will only construct what's in that region. So it makes it very, very nice. And I'll kind of showcase this to you here, where, okay, so I'm going to go through and where basically I hit the set reconstruction region here. And as you can see, like now I have like these colored dots. And if I like drag stuff in, you see this like box moving with me. And what this box is this box is telling us like, okay, like how do you actually want to reconstruct our 3D mesh? And so what I can do is I can actually align our 3D mesh, or sorry, our reconstruction region with the exact locations that I want the algorithm to actually calculate. And what we can do with it is we can actually make it so that we try to shrink it down into only the most important parts so that it's able to give us the utmost best fidelity by constructing just against the smaller regions that we need. Plus, it'll take a lot less time over, you know, larger regions take way longer to process because the algorithm has to calculate against more and more and more space, images, and of course, points in the point cloud. So now that we've taken a look at that, I'm not going to reconstruct. I'm not going to actually like run a reconstruction because that will take a while. But I wanted to point it out because it's very, very important to be able to navigate that and look at that. But the next thing I want to kind of quickly start talking about is like a bit of mesh cleanup. So how do we go about like actually starting to clean things up? And this is kind of where you start to get into things like simplification, checking your topology, your level of detail, and you can really like start to go and make make these scenarios as nice as you want. Like make the mesh as not only as dense as you want, but also as simplified as you want. And so that's what really allows us to start to clean up our not only our mesh for export, but it also provides us with ways to control what the mesh is going to look and behave like in another either DCC like Blender or Max or Maya, or of course a game engine like Unreal. So we will go through and we'll chat a little bit about what the simplification and the LODs are like shortly after. One thing I would like to kind of point out is that you can always flip between um, basically like your point cloud, so your point cloud view, as well as your solid view, which is your basically your meshed view. Um, the suite view is what's called a full render. So if you happen to have a texture already done on it, you can actually see what the texture looks like. So if I go to my high quality base here, it's going to load up let's see, it's going to load up what the solid view, so basically the untextured view. And once it's slowly loaded this up, we'll switch to suite, which will give us the textured output. So I'm just going to go ahead and while it's doing this, perfect. So now we're getting there. So now I'm just going to hit the suite, and now it's gonna basically apply our texture to it. And you can at any time you can go through and you can do an unwrap or texture process. And to do that, if you actually just click on the mesh model and then texture, it will give you the ability to go through and start to basically what will happen is it'll go through and it'll apply the images as a texture to our stump in this case. If you're curious about how to like maybe set like unwrap settings, so unwrapping is basically the concept of taking our 3D object and basically making it so that we can wrap wrapping paper around it. And so the wrapping paper in our case is going to be the photos that we've taken as our texture. And and so what we need to do first before we can actually do that is we need to tell, or RealityScan needs to be able to tell where it can apply each individual color or texel, um, which is basically like a texture. It's basically a portion of a texture to the 3D mesh in 3D space. It's it can be quite complicated, but basically the core idea is that you want to balance both texture amount with texture, texture size. So you want to look at ways to try to make it so either you are you you may have texture size limits depending on the type of game, um, and texture count limits as well, if depending on what you're trying to achieve. So if you do have those, you want to make sure that during the unwrapping process you're only unwrapping uh, the amount of textures that you absolutely require to unwrap, instead of like basically creating higher, maybe instead of like a 2048 by 2048 pixeled image, maybe you can create a 1024 by 1024 image for your texture instead. And that way it kind of helps balance it all out, and it makes it a lot more efficient for your game engine or DCC of choice to actually be able to render it. So really quickly, when I have my unwrap selected here, in my unwrap tool, you can actually go through and you can change a lot of these settings. So you can change the minimum and maximum texture resolution. So this is kind of the image size that will be generated out of this like unwrapping process. So basically you can kind of hard set like, okay, I always want you to be outputting 1024 by 1024 images. Well, you could just basically set the minimum and maximum to that, and that would resolve that. Unwrapping method, there's a couple different unwrapping methods. So geometric is kind of like it's a faster methodology that basically the way that it works is it will apologies, it will basically it will make it so that it's faster to compute because it's actually like going directly, it's applying directly to the mesh. Um, even when it's like larger meshes, it's really, really good for being able to quickly iterate upon different unwrapping strategies. So like if you aren't sure on the exact sizing of things, you can always check that kind of stuff out. And then mosaic, which is mosaic is kind of like a newer strategy, at least in RealityScan, for basically it is a more optimized solution for real-time rendering, but at the I guess the downside of speed, it's not nearly as fast. It takes quite a bit longer to do a mosaic than it does a geometric. Alrighty, so with that done, so you've gone through, you've unwrapped. You can always calculate once you've done that using choosing your unwrapping style. You have a couple different options. You can like put a hard texture limit for count. You can set a texel size or an adaptive texel size. What for quality of out, like I guess like texture quality, if you have the flexibility, it's always nice to be able to do like basically fixed texel size and then do a texel size of optimal. This way it gets basically, it tries to extract out about 100% of the overall texture quality from the images. And so in a perfect world where if you had no restrictions on anything, this would be kind of like an ideal output. Then you can either calculate the unwrap or you can actually just hit the texture button, which will kind of combine unwrapping mixed with texturing based on the settings that you choose. Alrighty, so we've gone through and we've kind of taken a look at the texture and kind of like how to go about texturing. Whoops, my my viewport is quite laggy due to just how large this mesh is. And so once you start to kind of go through and start to do that, then you'll find that you'll want to actually start to do something called filtering. And what filtering is this ideology where we're going to go through and we can actually start to select triangles that are like part of our mesh, and we can actually go through and do something called filtering them out. So it basically removes them from our overall mesh. And to do this, what you can actually do is when you have your mesh selected here, you can actually go in, and there is a few different like tools here, like a lasso tool, a rectangle tool, a box tool, or you can do like advanced selections based on like angles of, you know, whatever angles the triangles are at. I like the lasso tool and the rectangle tool. I'll just kind of show you how this kind of works. But basically, if I choose my rectangle tool and I want to delete everything in here, as you can see, it kind of like gives like a darker shade of gray. And so I've selected all of that, and now I'm going to release my mouse, and it kind of gives me like an orangey tint. And once that's selected, if I go filter selection, it's going to go through and it's going to filter. So it's going to remove those triangles from that mesh. And when it does that, it at the very bottom of my list, or wherever, like you know, depending on how many instances you've created, it'll create a brand new model for every single time you filter. My recommendation is to always try to remove models that you're not going to use, because honestly, like, it just, these projects can get so huge that everything just ends up taking up so much space, and it's not very performant. So I always recommend that, like, unless you're moving in the, well, when you're filtering, especially when you're filtering and doing stuff like that, I heavily recommend you delete the older models. So I'm going to delete that. And the next, you know, so basically you can go through and you can filter out that way, and you can start to like remove large swaths of area that you don't necessarily want in your finalized mesh. So it provides a lot of flexibility there, just using those tools. And it's really, really cool because since it's all in RealityScan, you still keep that overall, not only the point cloud, but the texture quality that you're going to get out of it. It's like, since you're not moving it between different DCCs like Blender, Max, Maya, and back, like you're able to retain the flexibility to basically resample textures, and it makes it very, very nice from a quality and stability standpoint. The next thing I want to kind of showcase is like the simplification. So like basically what simplifying will do for us. And what's really neat is when you left click on this, I'm just going to unclick my rectangle tool so that I'm not selecting things for filtering. But when I have my simplify tool selected, over on the left hand side here, it gives you like some really, really good options. And what it allows you to do is it allows you to do things like, okay, do I want like to set an absolute like triangle count? Like, so okay, I want my mesh to be this exact amount, a relative amount, or like kind of like a max and a min depending on what you're trying to achieve. For simplification, I mean, I personally like the absolute, like, overall. I've found that the absolute kind of works well for my use cases. And then you can actually type in an exact target triangle count, and it will actually it will basically decimate or remove combine triangles to basically make a lower detail mesh, but one that will run more efficiently in your engine or software of choice. So I'm going to flip now to basically a 1 million triangle mesh. And what I've done is I've done something called reprojecting the texture. And as we were talking about before, we were talking about how you can go about and actually create a texture based on a high density model and use the high density model as our way of capturing the most detail out of the images as possible. And so once we have that, we can then go through and basically slap that wallpaper onto a lower density one, or a mesh that is like a fraction of that amount. And so, for example, in this case, this mesh is only a million polygons, or sorry, a million triangles, apologies. But what I've done is I've taken the texture from my 265.6 million triangle one, and I've done something called reprojecting it onto the 1 million triangle counted one. And it's really, really neat because what you can do is to do that, all you have to do, it's in the exact same spot. So we're under Scene 3D Tools. And instead of Simplify, I'm going to uncheck Simplify, and I'm going to click on Texture Reprojection. And underneath kind of our little our kind of panel, our top panel here, it says Reproject Model Texture. And so now you can actually go through and you can choose your source model. So what model do I want to use as my texture base? And where do I want to project that texture onto? So in this case, you know, I could put it onto any other type of mesh, and I want to make sure that the reprojection is there. I want to make sure everything like that, and then you can just hit reproject texture, and it will take that highly detailed texture that it created on that, you know, hundreds of millions of triangle mesh, and it will apply it to one that's a fraction, right? Like in this case, like the difference in polygon or a triangle count is like, it's like 1/265th, right? And you can still get very, very, very nice output, right? Just from that. It's crazy what you can do. And so then you can kind of continue on down this line where it's like, okay, I have this absolutely fabulous, you know, fabulous looking quality mesh, and I've reprojected the texture on it. I've gone through and I've done all of those types of things. Well, you can actually go through and you can verify, because more often than not, you're going to want to make sure that your mesh is kind of it's a complete mesh. It's, you know, you want to make sure that it doesn't have any holes in it. And to do that, what you can do is that you can actually go to like this mesh model heading here, and you can choose things like check integrity. So it'll basically check to make sure that there's no like corrupted files or anything. You can check the topology, so it'll make sure that the topology and the mesh all looks appropriate. And then you can do something called cleaning the model. So what cleaning the model will do is it'll remove, if there is any topological issues, it will clean that up for us. And so I heavily always recommend doing that, especially after you've decimated or simplified, because it is possible for the algorithm to accidentally leave kind of remnants behind that you may not want. So cleaning up the model always makes it nice. I definitely always also recommend closing holes of the mesh. It just helps kind of clean things up. But you can kind of go through and you can kind of continue on decimating, right? And so you can start to like get basically lower and lower and lower resolution, lower triangle counted outputs, but then you just keep reprojecting that super high resolution texture that you did earlier on. you just keep reprojecting it onto like more and more and more of these like meshes that have less triangles. So in this case, like we've gone from a 265.6 million triangle mesh to a 83.5 million triangle mesh to a 1 million triangle mesh to a 10,000 triangle mesh. And the texture did a really good job at being able to maintain all of that for us. It still blows my mind. Just every time I look at this, like just what you can do just by basically doing it, like baking in a texture. It's just incredible. So once we have that, then now we can kind of think about like, okay, what do we want for our other types of output? And I'm sitting here and I'm looking at my slide deck, and we've gone through quite a few of this already, like the reconstruction region, mesh, a bit of mesh cleanup, texturing fundamentals. We've talked extensively about mesh simplification. We briefly went over texture count and size. So texture count and size is very important based on whatever type of output you are looking to achieve. So obviously for like a game, you wouldn't want to be doing like, 16K textures for like a tree. That wouldn't be very performant. But it's all, again, it's all about like what your type of output is and like what you're trying to achieve. Games often, like I think the absolute, like what you would classify as almost like raw quality or like highest quality are usually 8K textures, but most of the time games don't actually use the 8K texture. They might use up to 4K. Um, And then, of course, level of details. And level of details is very important because it helps you balance between visual fidelity and performance based on how far away your camera is from that particular object in your engine of choice or your software of choice. For those who are getting into basically extracting out levels of detail, what's really neat is if what you can actually do is at the when you're in kind of like your mesh view, if you click on Scene 3D and then Tools, there's levels of detail, and if you left click on that, it will ask you where you want to save your level of detail and what type of export you want to do. And so you can, of course, do pretty much anything. But if I click OBJ and I go save, it's then going to ask me like, okay, like what do I want for my level of detail settings? So when do I want level of details to stop? So do I want it to be at a triangle limit, a model count? So what's good is like if you want to have like say 4 level of details, like say LOD 0 to LOD 3, you could just type in 4 into your model count. And then how do you want your simplification type? Do you want it relative or absolute? If you want it, you could, in cases like this where you're basically doing large amounts of simplification meshing, relative may work very well for you here because then you don't have to worry about typing in exact numbers. So you can scale down in percentages. And then, of course, you may want to, if you want to export the textures or not, you can, of course, do that. But level of detail is very, very important for making sure that you're able to achieve the quality of output that not only the quality of output, but the performance of output that you're looking for. And yeah, rendering in RealityScan. So we've kind of gone through a bit of the ideology behind like how do we get like a good mesh output? How do we go through and we make sure to try to get the highest quality texturing. And what's really neat here is Reality Capture has some absolutely fabulous animation and capturing tools. So if I want to go through and I want to capture a still, all I got to do is I just go to workflow, and then I can go to render image. And then it's going to ask me, oh, how do I want my image rendered? Do I want it to be colored? Do I want it to be just kind of a shaded view? Do I want it to have a composite look? What resolution? What type of shading do I want? Do I want like flat wireframe, flat, smooth? Color type, do I want a texture or vertex coloring? What do I want my background color, etc. And if we just quickly go back to my slides here, so this top right one is it's basically a 4K image that's flat wireframe shaded, and so that's how you can kind of see what the triangles look like. And then the bottom is basically it's a smooth textured look. And then on the left hand side, this is like an actual animation video that you're actually able to kind of play out. And it's really cool that you can do this so quickly, because it makes it so that you are able to really showcase to, either, your internal team or to clients kind of what your output was like. So if I want to go through and I want to actually create like basically like a video, um, basically what I'm going to want to do is I'm going to do kind of this 1-1-1 view here at the top, and I'm going to change this 2D view to a 4D view. And let's see here. There we go. Okay. So now that we're in this kind of basically this view, and I have my 4Ds open. Now what it allows me to do is it allows me to actually like kind of not only create a camera, but choose and actually keyframe how I want this to kind of play out. So as you can see, there's like an actual virtual camera here that's pointed towards my stump. And what you can actually do is if you hit play, you can actually start to like kind of see how it all is going to work together. And you can start to go through and create a bit of a nice animated fly through or flyover, depending on whatever it is that you're trying to do. And it makes it really, really nice to be able to kind of showcase that type of stuff. So what I've done is I've gone through and I've just deleted, I just kind of quickly paused and I deleted my animation track here, and I just kind of want to show you how easy this is. So I'm just going to set it to 0, 0. I'm going to hit add. So now what it's done is it's added a digital camera into my frame or into my scene. And so now with this selected, now what I can do is I can actually, if I scrub with my little scrubber thing to say 10 seconds, whoop, if I can choose my, apologies about that. If I click on my little camera here and I hit the little add, now my screen's gonna be gray. And so now if I like scrub a little bit to the right, and then I move my keyframe, say to 10 seconds, and say I move over here, I'm going to now add another keyframe, and you're going to see that it's now added another camera. And I now have a blue line between the two. And so what's neat is if I click stop and then I hit play, you're going to be able to see that animation play out. And it's really neat because all you have to do is just hit render and save, and you can save out like a quick video, and uh, it'll all look good, and everything it'll all behave exactly as you want. So that is animating and rendering out in RealityScan. So I'm just gonna flip back to my slide, and I'm just gonna quickly recap a little bit of what we've gone over today. We've gone over everything from like the workflow of aligning, meshing, a bit of refining and optimizing, the texturing strategies, and just how important, especially alignment is. Alignment is vital. Like, to make sure that you have that solid foundation is extremely, extremely important. And because you can't get a really high quality mesh without proper alignment. So it's very, very, very important. Then, of course, refining and optimizing your mesh. So through techniques such as filtering, simplifying, utilizing your LODs, um, texturing, obviously making sure that you choose appropriate texture sizes, texture counts, and always be reprojecting that high quality texture onto lower triangle meshes. Like, that's really where you're going to get really solid output. And then, of course, being able to render things out, like rendering and exporting, because you can export in so many different uh, file types, everything from like OBJs to FBX. I'll just quickly flip back and show you how to kind of go about doing that. But basically, if you have your tool, or sorry, you're in your scene 3D. If you go to mesh and point cloud, now you can start to export in all sorts of different formats, and it's really, really great because you can this gives like a lot of flexibility as to how you want to go about it, because now you can import your mesh and textures into another DCC and start to do additional modifications, and you can really start to work and align the mesh to exactly what your project is calling for. And so once you've kind of gone through and you've been able to render and export things out, it kind of comes down to, just making sure that you are able to achieve the fidelity in your engine or software of choice, through a mixture of not only exporting out high quality textures and meshes, but also when you're creating materials in your engine of choice, just making sure that you apply proper shader techniques, because it's vitally, vitally important to also note that in RealityScan, the mesh that you're looking at is always what you would classify as an unlit or unshaded um, model. So it doesn't behave and it doesn't look that way if you shine light at it. You have to really make sure that you design your materials in your DCC or engine of choice, with basically in ways that would properly react based on whatever it is that you scanned. And that's just one, that's definitely like a hiccup that can really catch people, is the fundamental understanding that when you're in RealityScan, it's operating under basically the unlit mode. So with that, I wanted to thank you all for listening to my presentation and to my class on kind of a dive into the RealityScan workflows. So after you've gone out and you've taken your images, how do you go about like aligning, meshing, refining, optimizing, texturing, rendering, and exporting it? It's quite a fun piece of software, and there's just so much potential, and it just continues to improve and continues to get better, and I cannot wait to see what you all are able to produce. Thank you very much, and take care.